to all of you. I'll send it out to everybody. That way you'll just have it, and you can use it to look over or pass on to staff or whatever you need to do with that. So that will be available. I will also send out certificates for your attendance. Unfortunately, we can't offer CEUs. I wish we could. And I know a certificate isn't much, but at least it's a little something to put in your file. So with that, I'm going to introduce Skip Johnson. Skip and I have worked together on other presentations, and he has a lot of good information and knowledge that I think you can benefit from very much so. So welcome, Skip, and he's going to take it away.
Thanks, Mindy. Grab the controls here.
I'll switch places with him.
Okay. If anybody has any questions about how they follow along, you can probably jump in right now if you wanted to get a quick question in about how the program works or anything. If not, we're going to get started. There's my information there, a little bit about how I got where I'm at today, some of the different associations that I'm a member of. I've been doing fire sprinklers since 1989. I started off as an estimator, project manager, and then went into sales, and then it's kind of my current role right now. So what we're going to go over today is a little bit about sprinkler systems, and some of this may be a little overview for you guys. Some of you may not be, but we're going to talk a little bit about Sprinkler 101. I'm going to talk about the differences in types of sprinkler systems, myths and misinformation of sprinkler systems, sprinkler pipe bursts, which is something that we're getting ready to go into that season right now, owners' requirements for maintaining their sprinkler systems, periodic maintenance requirements, common problems that affect sprinkler performance, and then the most common deficiencies that we find from our inspections. So basically, there's two standards when it comes to fire sprinkler systems that we use. The first standard is the most common standard. It's NFPA 13. The other is NFPA 25. NFPA 13 goes over how you design sprinkler systems, what's allowed, the components, what are required, hydraulic calculations, so forth. NFPA 25 is the other standard, and it's kind of the wear and tear standard for sprinkler systems. The intent of NFPA 25 is not to tell you how to design a system or to even check to make sure that the system is designed correctly. It is there just to check to make sure that components of the sprinkler system are functioning the way they're supposed to be functioning. That's why they call it the wear and tear standard. We're unable to play this link right here, but if you guys get this electronically, this is Matt Klossman from NFPA 13, or NFPA, explaining a little bit about NFPA 13 and how it differs from some of the other standards. It's an interesting YouTube video. If you got time, I'd suggest you check it out. A little bit about NFPA. NFPA was founded in 1895 by a group of concerned fire officials, insurance companies, sprinkler contractors, and their primary goal was to come up with a standard of how to protect lives and safety. And it all pretty much started around textile mills, where if you got a textile mill fire, usually you lost part of the entire town. So that's how NFPA got its start. Today it's the world's most referenced standard for fire and life safety systems, not just in the United States, but all over the world. So there's two main, very common types of sprinkler systems. The first most common sprinkler system is just a regular wet pipe sprinkler system. The major components of a wet pipe sprinkler system are the sprinkler heads, you see right there on the branch lines themselves, the cross mains. This is the riser. That's what's referred to as a sprinkler riser. At the riser, you're going to have a main control valve, which is generally a backflow preventer. You've got a main drain, a way to drain the system. The alarm components on a wet pipe sprinkler system are a flow switch, which you'll usually find right about there on the riser. and you'll find tamper switches on the control valves. A flow switch will send a signal to the panel that water is flowing, and that'll alert you guys, the local AHJ. And then if anybody tampers with the control valve on a sprinkler system, it'll send a supervisory signal to the panel, and only to the panel, not to the monitoring company. You have the underground water supply that comes in the building right there. The other most common sprinkler system is a dry pipe sprinkler system. The components of a dry pipe sprinkler system are almost exactly the same as a wet pipe sprinkler system. However, you have a dry pipe sprinkler valve, and my arrow is pointing to it right there. How a dry pipe sprinkler system works is you have an air compressor. It's usually located by the sprinkler riser, and it puts compressed air in on top of this dry pipe sprinkler valve. Now there's a clapper that air is pushing down on top of the dry pipe valve, and the differential pressure is like 8 to 1. So the air is actually able to hold down that clapper valve. If any one of the sprinkler heads discharges because it's activated by heat, the air compressor can't keep up, and the differential pressure drops dramatically, and that clapper valve will violently come open, and you'll flood the sprinkler system. On a dry pipe sprinkler system, you have to be able to prove that you can get water to this most remote inspector's test connection within 60 seconds. And we're going to talk a little bit about pipe corrosion and how obstructions can slow that time down, but there's a few slides ahead. So those are the two major types of sprinkler systems. If anybody has questions about the difference in the two, chime in at any time. Why install fire sprinkler systems? Being as you guys are all pretty much in the industry, I think you understand the reason why, but these are some losses of lives, major losses of lives due to fire in buildings without fire sprinkler systems. And according to NFPA, your chances of dying in a building are 400 times greater than if it were not sprinkled. The first sprinkler head was patented in 1874 by Harry S. Parmalee. It was an automatic sprinkler head. It reacted to heat. Some of the earlier sprinkler heads are, you got an upright sprinkler head here from 1895. Another upright head, can't read that from here, but these are some old sprinkler heads that were actually manufactured by our company, Grinnell. Today's modern sprinkler heads are glass bulb sprinkler heads. They work under the same principle as thermal, like as a thermometer. And the bubble in each one of these glass bulbs, as heat rises, the bubble tries to rise, and with a limited space to rise, eventually the bubble will cause the glass bulb to shatter. The different colors represent the different temperatures that the sprinkler head will go off at. And you might ask, well, why would you want sprinkler heads to go off at different temperatures? Your standard sprinkler head that you have in most buildings is going to be this red one. It's going to go off between 135 to 70 degrees, 170 degrees. However, if you have a sprinkler head in a hot kitchen, you might want to use a sprinkler head that has a higher temperature. Or if you have a sprinkler head that's located at the roof level of a warehouse where it gets hot, you're going to want a sprinkler head that's up in the 212, 286 degree range. That explains what the different colors represent. I wish I could play this for you, but click on this link when you get a chance, or just copy and paste it into your internet, and it shows how a sprinkler head works. We're going to talk a little bit about that in a minute. Some other modern day sprinkler heads are your concealed sprinkler head. It's a fully concealed sprinkler head, sits flush with the rest of the ceiling. This is a glass bulb brass upright, chrome sidewall sprinkler head, and then a recessed chrome pendant sprinkler head. The other most common sprinkler head is a dry pendant sprinkler head. This sprinkler head has a barrel manufactured onto the sprinkler head itself, and the length of this barrel is whatever you want it to be. If you have a dry pipe sprinkler system, if you think back to a few slides ago where we had the dry pipe sprinkler system, You don't want water anywhere trapped in your system. So this head has a plug on the top of it that just threads right into the sprinkler branch line. If the head reacts to heat, the bulb breaks, the plunger comes out, and then that plug will shoot right out the bottom or through the sprinkler head, allowing water to enter the sprinkler drop. Dry pipe sprinkler systems have to have pitch on all of the branch lines. So as you move down a branch line and you've got a sprinkler head protruding through a ceiling on a dry pipe sprinkler system, every sprinkler barrel is going to be a little bit different than the other. If you're sloping far away from the branch line or the cross main, you're sloping, back to it, so the water will drain. A lot of people ask, why dry pendant sprinkler heads are so expensive and hard to replace. It's for that reason. If we come out to, say, a customer has a dry pendant sprinkler head that reacts to heat or is damaged, we have to come out and, one, measure the length from the face of the fitting on the sprinkler branch line to the deflector, order it, it comes back in, then we got to go back out to the customer site and install it. It's a little bit different than just carrying a standard sprinkler head on our service truck and going out to the truck and getting it and popping it in. A lot of people ask that question. Okay, this is something that you guys, it's really easy for everybody to identify. Quick response sprinkler heads cannot be mixed with standard response sprinkler heads. Quick response sprinkler heads are tested by the manufacturer to go off at a certain time, so before the fire reacts or grows to a point where it can't be controlled by sprinklers. If you have standard response sprinkler heads and quick response sprinkler heads mixed together within the same compartment, they're going off sporadically. They're not going off at the time that they were designed to go off at. So you might ask yourself, how do I tell the difference between a standard response sprinkler head and a quick response sprinkler head? And that's really easy. They're both glass bulb sprinkler heads, and you might assume that they're identical. Well, the 5 millimeter fat bulb is a standard response sprinkler head. And then the 3 millimeter bulb is a quick response sprinkler head. If you see these two sprinkler heads installed within the same compartment, a room or large room, a small room, if they're they can be in the same building, but they can't be together in the same compartment. If you see these two sprinkler heads together, that would be a deficiency. And they need to get the standard response sprinkler head changed out to a quick response or vice versa. That's pretty low-hanging fruit when you're on an inspection. Misinformation about sprinkler systems. According to Factory Mutual, only 1 out of 16 million sprinkler heads per year in service go off for just no reason whatsoever. Sprinkler heads do go off due to being struck, uninstalled, and then reinstalled. It's easy to damage a sprinkler head, and then it can seemingly go off because of a defect at a later date. Well, it's seldom ever a defect. It's damage. If one sprinkler head goes off, they all go off. That's not correct either. That only happens on TV. And clean water rarely ever comes out of a sprinkler head. So if you watch TV, you see them all go off at the same time and clean water comes out. That's a myth. So how a sprinkler head goes off, how a sprinkler head reacts to heat is depicted here in this slide. This slide here, the sprinkler head is, you can tell it's a standard response sprinkler head because it's got a fat bulb. And that's a red bulb, so that tells you that it's going to go off in between 100, right around 165 degrees. So it's sitting there in its static position. The heat has risen past 165 degrees here in this picture, and the glass bulb is burst. After the bulb is burst, the plunger starts to drop out, and then the mythical clean water shoots out of the sprinkler head. What is the life safety record for fully sprinklered building? And I might add that not just fully sprinklered, but properly maintained. Aside from firefighters, explosions, there hasn't been a multiple loss of life recorded for a fully sprinklered building that is maintained correctly. For decades, sprinklers have maintained an impressive 97% effectiveness in controlling fires. Most of our nation's deaths each year are elderly and young in unsprinklered building. And generally 2 or less sprinkler heads can control over 90% of fires. Another myth of sprinkler systems is that sprinkler systems are designed to extinguish fires, your standard sprinkler system. Standard sprinkler systems are designed to control fires until the AHJ firefighters arrive. But most times the sprinklers do put the fire out before the fire department does arrive. Pipe bursts. Most common cause for pipe bursts in wet pipe sprinkler systems, there's insufficient heat where the pipe is located. An example of that would be, a nursing home where they have a wet pipe sprinkler system and it's laying on top of the ceiling with insulation over the top of it. A lot of times that insulation gets kicked off by maintenance people or moved off of there. And then the wintertime comes around and that pipe freezes and breaks. Antifreeze solution mixtures are not checked and maintained. You've got to have the correct mixture of water with antifreeze in order to keep an antifreeze system from freezing and breaking. On dry pipe sprinkler systems, accidental trips not detected, or if you have a trip in the summertime of your dry system and the water is not all purged out correctly, then that wintertime rolls around, that freezes and breaks. This is a biggie. Low point drains are not maintained. We're going to talk about that here in a couple slides. And then another biggie is improper pitch on dry pipe sprinkler systems. As I stated earlier, that you have to have pitch on your sprinkler system. So the furthest sprinkler head out on a branch line, it's got to pitch its way back to the cross main that's pitching back to the riser to the main drain. If you have areas of the system that are trapped, that pipe still has to pitch back to low point drains. This is a dry pipe sprinkler system low point drain or a drum drip. If you owned a building with a dry pipe sprinkler system and you have these in your building, right now is the time that you really want us to go around and start purging these drains to get any condensation or trapped water in your system out, because it's going to get cold. So you have a ball valve on top of this drum drip and you have a ball valve on the bottom. What you do to purge these drains is you shut the bottom ball valve, open up the top ball valve, and then any water that's drained on top of there will come down into that barrel, shut that one, open that one, and purge that water out. You do it over and over and over until you don't get any water out. In the fall months, you want to be doing this on your low point drains every other week probably. And as wintertime gets even closer, you want to even step that up a little bit. But what happens is people think their sprinkler systems don't require any maintenance, or they just become invisible after a amount of time, and they don't drain these low point drains. So what happens with this top ball valve shut, that condensation or whatever trapped water might be in the dry pipe sprinkler system starts to collect on top of that top ball valve until it goes up into the attic area, and there's no heat in the attic. So as soon as it gets good and cold out, it breaks right up there above the ceiling in the attic. And we probably do, I'm betting we do 40 or 50 service calls a winter on that exact scenario. People aren't purging these drains and they freeze and break. And then they're shocked when they see how much water comes shooting out of a piece of 1 inch or 1.25 inch pipe that was meant to be a drain in their building. So the owner's requirements for maintaining the sprinkler system, that is talked about in NFPA 25. And NFPA, this is NFPA, this link here again is NFPA talking about the differences of NFPA 25 versus other standards. It's a good video to watch. But what is the scope and purpose of NFPA 25? This document is established to establish the minimum requirements for maintaining periodic testing, inspecting, and maintenance on water-based fire protection systems. The standard does not require the inspector to verify the adequacy of the design of the system, and the purpose is only to ensure a reasonable degree of protection for life safety and property. And that's not NFPA 13, this is NFPA 25 based on inspections. What does NFPA 25 say about maintaining your system? It basically says if during an inspection deficiencies are found, the owner is required to take care of those deficiencies promptly. Furthermore, they have to be taken care of by qualified people. And the NFPA does not really go into a lot of detail about what is qualified. NFPA 25 says the responsibility for maintaining the sprinkler system is of the building owner. Where the building owner is not the occupant, that can be passed down to the occupant as long as it's done in writing. And this is kind of a good clause for sprinkler contractors. I'm glad that's in NFPA 25. Companies like us are always being sued because sprinkler systems they don't work the way they were designed to work because of lack of maintenance. Whereas the sprinkler contractor can be writing up deficiencies and handing them to the building owner. The building owner is under no obligation to fix those things, no obligation to us. He's under obligation to fix them to be in compliance with code and local jurisdictions, but they don't necessarily have to. I like to think that if you're in a state-regulated building, you stand a much better chance of getting out of that building in a fire because it's being required to be maintained. If you're in a grocery store, there's no guarantee that anybody is forcing that sprinkler system owner to maintain their sprinkler system. Sprinkler head inspections. Sprinklers shall be inspected from the floor level annually. Any sprinkler head shall be replaced that has signs of leakage, is painted, corroded, damaged, or loaded, or in the proper orientation. Severely loaded or corroded sprinkler heads could be rejected or should be rejected as part of the visual inspection. However, lightly loaded or corroded sprinkler heads could be permitted for continued use if samples are selected for testing based on worst case conditions and the tests are successful. We'll talk a little bit about those tests coming up here, but when you guys are on your inspections, you should be inspecting sprinkler heads from the floor level, and you should be looking for sprinkler heads that have signs of leakage, that are painted, corroded, damaged, or loaded with like dust and contaminants. And those heads should be written up to be replaced. This is kind of a newer one. Quick response sprinkler heads that have been in service for 20 years shall be replaced or tested. Dry pendant sprinkler, then they have to be tested every 10 years after. Dry pendant sprinkler heads, we talked about those a few slides ago. If they've been in service for 10 years, they have to be replaced or tested. Where your standard, regular, run-of-the-mill, just regular wet pipe sprinkler systems, sprinkler heads are found, if they're 50 years old, they've got to be replaced or tested. So while you're on your inspections, you might just walk over to the sprinkler riser, and every sprinkler riser is supposed to have a spare sprinkler head box there with sprinkler heads in it that were from the initial installation. You can pull one of those sprinkler heads out of the box, and every sprinkler head is stamped with a date on it. If you've got quick response sprinkler heads that are over 20 years old, it needs to be written up that they need to be replaced or tested. 10 years for the dry heads and then 50 years for the standard heads. Again, that's pretty easy inspection, low-hanging fruit there.
So would that be a violation on the facility as well?
Yes, it would be it'd be a violation on for the sprinkler system.
Okay.
Sprinkler head inspections. So say you find a building that has a lot of quick response sprinkler heads that are 25 years old. All right, and I'm the building owner, or I've been cited for this, I'm going to get these heads tested. This is what NFPA 25 says about getting your sprinkler heads tested. They have to be tested by a recognized laboratory. We like to use Underwriters Laboratory, UL. Where one sprinkler head fails within a sample, then all of the sprinkler heads fail. So what that means is, say you've got a facility with 150 sprinkler heads total, and they're all quick response sprinkler heads, and they're all 25 years old. A representative sample would be about 4 sprinkler heads. That's out of NFPA 25. I take those 4 sprinkler heads from different locations throughout the entire building, and I send them off to UL. UL will put the sprinkler head in basically what's called a hot box, and they put water pressure on it, and they put the minimum required water pressure per that listing on that sprinkler head. They raise the water, the heat up in that box, and if the sprinkler head goes off at the temperature that it was supposed to, it's considered a normal test. If the sprinkler head doesn't go off, or it goes off after the heat is well surpassed the required heat of the sprinkler head, it's considered an abnormal test. So that sample is rejected for the entire building. If they would have come back normal, then every sprinkler head in their building would have been fine for another 10 years when it has to be tested again. If any one of those 4 sprinkler heads fail, every sprinkler head within that sample is considered failed, and then they have to replace every sprinkler head in the building. The 2008 edition of NFPA 25 came out and said that before this edition of NFPA 25 2008, NFPA just plainly said that you cannot clean sprinkler heads. There's just no way to clean them whatsoever. Well, the 2008 edition came out and said that you can clean sprinkler heads as long as you can do it by a blast of compressed air, or you can vacuum the contaminants off of it. It does go on to say if it requires any kind of scrubbing, wiping, or detergent, the sprinkler head shall be replaced. And that would be basically only loaded sprinkler heads. And you might ask yourself, what is a loaded sprinkler head? This would be a loaded sprinkler head. I took this picture, I probably shouldn't say where, but right before I was ready to give a presentation to the Missouri Fire Marshals Association. This is where we were all at, and I noticed that all their sprinkler heads were loaded. So what they've got here is they've got you can tell it's got a fat bulb, it's a semi-recessed chrome standard response sprinkler head, and it's got junk all over it. So if you had a blast of compressed air, it would probably knock that off, or you could vacuum that off. But that would be the only means acceptable by code for cleaning a sprinkler head. If you've got paint on any part of the sprinkler head, the arm, the frame, the deflector, the fusible element, it has to be rejected and replaced. And if the code book doesn't say anything about the escutcheon plate, so I've seen a lot of escutcheons with splashes of sheetrock mud or paint on the escutcheon. I would consider that okay, but if any of that gets on the sprinkler head itself, it has to be rejected as part of that inspection. I mentioned spare sprinkler heads a little while ago. Every sprinkler system is required to have a spare stock of sprinkler heads for the building. The minimum requirement is 6. The sprinkler heads have to correspond to the type of sprinkler heads within the facility. Furthermore, you have to have a sprinkler wrench in the head box for that sprinkler head. Where you have a building with nothing but dry pendant sprinkler heads, NFPA 25 realizes that every one of those dry pendant sprinkler heads are going to be a different length, and there's no reason to keep a spare stock of them around, but you have to have means to put a temporary sprinkler head in that dry pendant if it goes off. So if you're out on your inspections and you see a building with a variety of different types of sprinklers, and some of them are dry pendant sprinkler heads, it's not a requirement per NFPA to keep a spare dry pendant sprinkler head with that head box. If you've got a building with 300 or less sprinkler heads, you're required to have no fewer than 6 spare sprinkler heads. For buildings with 300 to 1,000 sprinkler heads, you can have no fewer than 12 spare sprinkler heads. And it goes on for buildings over 1,000, you have to have 24. You have to have a wrench that corresponds to each type of sprinkler head as well. Sprinkler gauges shall be replaced or tested every 5 years. we don't get a lot of requests to have gauges calibrated. It costs about 10 times more to calibrate a sprinkler gauge than it is to just to replace a sprinkler gauge. I know that we carry a stock of gauges on our trucks, and if we notice that gauges are over 5 years, we can sell the customer a sprinkler gauge right there on the spot. Every sprinkler gauge has got a date written on the face of it too, so there's not a lot of guessing work. If you don't see a date in the sprinkler on the gauge itself, you might question whether that's a ULFM approved device. Mindy's, had you mailed this out or emailed it? Mindy's going to go ahead and send you guys this cheat sheet. It's kind of a nice, basically it's a cheat sheet of all your inspections. On this side of the page are all of the visual inspections that are required for all fire life safety systems and the intervals that those visual inspections are required. On the flip side of that are all the functional testing requirements for all fire and life safety systems and the intervals that those are required. So it's not just for sprinkler, it's fire alarm, it's kitchen hood suppression, it's sensitivity testing on fire alarm. It's just all the things that you wanted to know compressed about inspections into 1 or 2 pages.
We use this cheat sheet a lot too when our inspectors are out in facilities. They'll give the facility maintenance or operations or whoever this so that they have a copy of it as well, so they're aware of it's a good tool to have.
I've had some facilities take all the information off of these sheets and put it into an Excel spreadsheet with calendar date reminders, so that when the inspections that they're required to be doing themselves come up, they're being dinged for it and they're not missing anything. So, and I think what Mindy's getting ready to send out takes into consideration the latest codes. I know a lot of you guys are not on the latest codes, but I think that you guys can accept those, can't you?
For which one?
For all of the life safety systems. So say that they're on the 2007 edition of NFPA 213, but this takes into consideration the 2013 edition of NFPA 13.
Yes, we can. And I know, yeah, absolutely. And that's one of the things I was going to mention was as far as our code updates, just so you know, we're still in the process of it. We got held up because our attorney that was taking a look at the code adoptions actually left, and we got a new attorney, so that has slowed things up. So it's coming eventually. We just aren't quite sure when.
Backflow preventers are required to be tested annually, and they have to be done by certified technicians, not qualified technicians, but certified technicians. And a lot of plumbers are certified. Fire life safety companies are certified. And what we do is we find that a lot of plumbers will inspect our fire backflows, and we do a lot of inspections on other backflows in the facilities, not just the fire sprinkler ones, but they have to be tested annually by certified personnel. Periodic maintenance for fire sprinkler systems. This is kind of a biggie, and I would assume that you guys have all started to look at this, but obstruction investigations. Every 5 years, an investigation of piping and branch line conditions shall be conducted by opening a flushing connection at the end of a main and by removing a sprinkler towards the end of the branch line for the investigation of foreign, organic, or inorganic material. Talk a little bit more about that. These are the points of the system where we do our inspections for the 5-year obstruction investigation. If an obstruction investigation is carried out in accordance with this section, finds significant material to obstruct a sprinkler, a complete flushing program shall be carried out. So if we go out and we find that a system during our 5-year obstruction investigation is questionable about having obstructing debris in it, what we'll do is NFPA 25 tells us that we can go and flush a representative sample of sprinkler branch lines, which is 3 generally, and a representative sample of mains, which is 1. We'll flush those branch lines and mains, and we'll capture what comes out through burlap bags. If what comes out of those burlap bags is less than a cup of scale, the scale fragments aren't large enough to plug a sprinkler head, or full unobstructed flow is obtained, then you can say that system is reasonably free of obstructing material and consider it okay. If you don't get that, then you have to do a full flushing investigation. That's where you flush every sprinkler branch line and every sprinkler main. And this is what it tells you how to do that. And that can be a considerable expense for a facility, because you've got to run 1.5-inch hoses off of the end of every sprinkler branch line, and you've got to run those to daylight, and you flush all the way backwards back to the riser, so you're not reintroducing other obstructing material into the lines that you just flushed. It's very labor intensive, and it generally costs quite a bit of money, but it's a very common problem that we've seen a ton of these sprinkler systems that are filled with crud, and you know they're not going to operate the way they were designed. So if you've got a severely obstructed sprinkler system and the first sprinkler head fails to open and that fire continues to grow, additional sprinkler heads are failing to open, or more heads are trying to operate than the system was designed to operate at once, the fire can grow out of control and it can threaten the structural integrity of the building. These are the most common obstruction sources that we see: pipe scale, careless installation or repair. This, I think, is referring to more of like if you have an underground main break outside of your building and gravel gets pushed into the system. Well, every year you're required to flow water out on your wet system. You're required to flow water out of your west systems. Well, that debris and gravel can get washed back into the system. We had a fire out at Cabela's out here in Kansas City, Kansas, and the sprinkler head went off and it did what it was designed to do. The fire went out, and when we went out to replace the sprinkler head, we found a piece of gravel lodged in the end of the sprinkler head. Still was able to get enough water out to put the fire out, but that's what careless installation or repair could mean. We don't see a lot of raw water sources. You can imagine the stuff that comes in out of a raw water source. Biological growth is actually a biggie. We're going to talk about that here coming up. Sprinkler calcium and carbonate deposits is another one. This is, when we talk about the biological growth, this is what is being referred to as MIC, microbiologically influenced corrosion. It's a bacteria that is in some water supplies that lives and grows and thrives on metal. This is a picture from some of our own inspections, and I have lots more of this junk that's just growing inside the sprinkler system. So you can imagine if you got a sprinkler head, you got a 1/2-inch orifice sprinkler head that's way out of the end of this branch line going out that way, and it goes off, and then you're moving all this water and whatever that is, that stuff growing inside the sprinkler system through that 1.25-inch branch line, which reduces down to 1 inch and is trying to come out a 1/2-inch orifice. You can imagine how much water you're going to get out of your sprinkler system, and that fire is going to continue to grow, and the sprinkler system's not going to be able to keep up with it. So microbiologic influenced corrosion is a very common thing out there nowadays. We're seeing a lot of it. This is inside face of a dry pipe sprinkler valve, and that stuff is growing inside of there too. If we find the presence of this, what we like to recommend is we do a water analysis. So we'll take a sample of the water out of the sprinkler system. We'll send it off to Potter Laboratories. That's who we like to use. There are others, and they'll study that water, and they'll send you back. It's like a book what you get back, a report of how much bacteria is in the water. Is it MIC? Is it not MIC? And should there be any reason for concern? If you do find that you have MIC in your systems and your wet pipe sprinkler systems, there are ways to mitigate that. Potter makes another product called Pipe Shield, where you can put it in your system and it kills that bacteria. So we would go in and we'd flush the system free of all of the obstructing material, and then we would install that pipe shield system to mitigate any future microbiologically influenced corrosion. If you have a dry pipe sprinkler system, you can still have microbiologically influenced corrosion, and the way to mitigate that is, this is new technology, is by installing, obviously, one, you're going to flush all the debris out, get it cleaned up, and then install a nitrogen generator air compressor. So you replace the air compressor on the dry pipe sprinkler system with a nitrogen generator, and it's not as expensive as it sounds, but the nitrogen generator pushes nitrogen in the sprinkler system instead of oxygen. As the system gets completely freed of oxygen, nothing can grow in that system. Furthermore, a nitrogen generator will help dry systems out where you have improper pitch on your sprinkler systems and you just can't get that water out from condensation. Well, a nitrogen generator will absorb all that water, and it'll mitigate water and corrosion out of the sprinkler system. The new edition of NFPA 13 has come out to say that non-metallic systems, in other words, plastic sprinkler systems, CPVC, it's an approved type of material for wet pipe sprinkler systems, are not required to have 5-year obstruction investigations. And if I was the authority having jurisdiction, I would probably still continue to ask them to do 5-year obstruction investigations. You're not going to get biologically influenced corrosion, or the systems is not going to corrode because it's a plastic system. I understand that. However, you can have foreign objects introduced into the sprinkler system, say from an underground fire main break. And I think the system should be, whether they're plastic or steel, they should be checked to make sure that there's not obstructions in the system. However, the new 2013 edition of NFPA 25 says plastic systems don't have to be inspected. Now, I do agree with this other statement that they make, that, let me see, where is it? If you have buildings with multiple systems, so say you've got a warehouse with 6 or 7 sprinkler systems in it, NFPA 25 2013 edition says you're allowed to do an obstruction investigation on every other system. Now, the next 5 years roll around, then you inspect the systems that weren't inspected. And this is just to help the building owners save a little bit of money. Is if you have a building with multiple systems in it, it can get kind of pricey to do these 5-year obstruction investigations on every single system. Common problems affecting sprinkler systems. Reconditioned sprinkler heads. We talked a little bit about, sprinkler heads don't go off for any reason whatsoever. This is the 2010 edition of NFPA 13, and it's kind of vague when it says reconditioned sprinkler parts. Well, I read that, and I interpret that as if you use a sprinkler head, if you take a sprinkler head out because you're moving walls, doing renovations, whatever, you don't put that sprinkler head back in. Well, since that was a little vague, the 2013 edition of NFPA 13 came out and they said it bluntly. If you take a sprinkler head out for any reason, you've got to put a new one back in its place. Sprinkler obstructions, this is kind of a biggie. If you have sprinkler heads that are located right next to a soffit or a pillar and it's obstructing the sprinkler heads have to be spaced to spray around and under obstructions. So bulkheads, solid beams. If you've got a question if a sprinkler head is installed too close to the beams, there's no magic rule that you just say, okay, well, it's 7 inches. It's got to be 7. There's no rule. You've got to go back to NFPA 13 and go to the actual page that there's a formula that you got to work out, and it's going to be different for every distance away from obstruction and the depth of the obstruction. So I encourage you, if you don't have a copy of NFPA 13, to get one. And if you suspect that sprinkler heads are being obstructed as part of your inspection, you need to get that table out and do that math. If you're in an area that's an exposed type of construction open to the deck, and you have obstructions that are over 4 feet wide, say like a big duct, air duct, if it's over 48 inches and it's entirely below the overhead sprinkler system, you have to install sprinkler heads below that obstruction and well because it's over 48 inches. You know, furniture can be below sprinkler heads too, and it can be well over 48 inches, but it's not the intention of NFPA 13 to sprinkler furniture. So it's just referring to mechanical things that are up in the air, or aesthetic ceilings that maybe you have a floating ceiling that is open to areas around it. If it's over 48 inches, you got to install sprinkler heads in that as well. Now, in regard to obstructions, the new 2013 edition of NFPA 13 did come out and say that some shadowing is okay. So in areas that are formed on the floor adjacent to their referenced architectural features, these shadow areas are purely on paper and do not take into account the dynamics of a sprinkler system. So if you're in a room and there's a beam that protrudes from the wall, maybe 14 inches, 12 or 14 inches, and you can tuck yourself up next to that beam and see that the sprinkler head wouldn't be able to spray water on you, that would actually be what's considered shadowing. It's not obstructions, but it's just a shadow. The intent of sprinkler systems is to sprinkle the floor area, and the sprinkler head is going to do that regardless, whether there's a shadow or not. This is a real big one. You see this a lot in long-term care, where you have a shelf with a sprinkler, or you have a closet with a shelf in it, and there's a sprinkler head at the top of the closet. Well, you have to maintain 18 inches from the bottom of that deflector to the top of any storage. So if you're stacking stuff up on top of that shelf, and the storage gets up within 18 inches of the deflector, that's a no-no. You have to either lower that storage or make them remove that shelf. And I would suggest remove the shelf, because they can lower the storage, and then the next tenant comes in and they don't know, and then you've got the same issue. If in a tenant finish upgrade or tenant improvements, if you're using if you want to just add extended coverage sprinkler heads without proving them hydraulically, you can't do that. If you're doing tenant finishes within a building that has no extended coverage heads, you can't just go add extended coverage heads unless you want to prove it hydraulically. You might ask, how do you tell what an extended coverage sprinkler head is? An extended coverage sprinkler head is going to have there's going to be something noticeably different about it than a standard sprinkler head. This extended coverage sprinkler head, you can tell that there's something different about it because of the big shape, the size of the deflector. Your standard sprinkler head has just a small deflector. Sometimes on an extended coverage sprinkler head, you have something sticking out, and I forget the exact term for it, but it's like something protrudes out of the end of it. There's something that you can look at and say, that's not a normal sprinkler head. Generally, that's telling you that it's an extended coverage sprinkler head. We talked about this a little while ago. Dry pipe sprinkler systems have to have pitch on them. So this is a dry pipe sprinkler system. All the water that could be in these lines has got to be able to drain. So it should be pitching backwards to this cross main. This cross main is pitching backwards to the riser and this drain. If you have areas of the building where your lines got to go up and down and over things, well, they've got to go back to a low point drain, an auxiliary drain somewhere else. If the water can't drain back to this drain, it's got to drain to some other drain. You can't have water sitting in your dry pipe sprinkler system because it'll freeze and break for obvious reasons. If you're doing an inspection on a building that's gone through some recent renovations, you need to check the sprinkler head spacing. It's very common for people to neglect and not even know that if they move their walls around, their sprinkler heads are likely going to need to be moved as well too. So if you go into a building where you're doing an inspection on I don't know, any kind of inspection, and say it's an inspection to approve the above ceiling electrical before they get their C of O, you need to be asking them, hey, did you take into consider your sprinkler head spacing? Hang on, I'll try to read. I'm not sure. Did you understand that question?
Can you go back up and we'll just read it? There was a comment that came in, NFPA 25 2014 edition, chapter 14 switches the terms for internal versus obstruction terminology. It requires only an internal inspection every 5 years. This is significant because our local contractors charge much more for an obstruction investigation than an internal. So just to share that there, thank you.
Okay, the most common deficiencies that we find during our inspections, internal obstruction investigations are not carried out, and it's easy to tell if these are being done or they're not being done, because if you go to the sprinkler riser, they should be tagged, and it's a tag that says 5-year obstruction investigation, and there's different check marks. Did it pass this? Did it fail that? So if you question it, you should be able to walk right to the riser and see the tag. If they don't have a tag, ask them and say, well, then show me your obstruction investigation results. And if they can't produce them, then they probably need to get that done. We're seeing a lot of systems that are obstructed with foreign organic or inorganic materials. Missing fire department caps, that's very common. Spare sprinkler head and wrenches are not the right type, or they're missing out of the head boxes. Dry pendant sprinkler heads are over 10 years old. This is a real biggie. This, and I would probably add the quick response sprinkler heads. People just don't know to check that. It's not very common. So we're seeing a lot of that. Backflow preventers have failed their inspections. Corroded, loaded, and painted sprinkler heads, we see that a lot. And then escutcheon plates missing. And the escutcheon plates are required because it is part of the listed device. So a sprinkler head that's in a ceiling without its escutcheon is not a complete listed device. So with that, we can go ahead and open it up for questions.
Good.
We may have gone a little fast.
Well, we're close on time. I mean, we're good on time, actually. So any comments or questions or anything like that you would like to ask, please unmute yourself if you haven't already, and feel free to ask Skip. And if you have questions after we're finished, you can feel free to send them to Skip or myself. His information's on there. Again, I will send this presentation out for you all to have. So we'll open it up. Let me ask, is there anything that we did not cover that maybe you wished we would have or would like to see covered in the future? Because this is information I need to be able to get it out there to you all. Okay.
That was easy.
Well, we certainly appreciate y'all being here, and we appreciate Skip coming and answering questions. And please, again, feel free to, as you're out on inspections or something comes up and you have questions, again, we're always there to help. So
I'm glad to answer any questions you guys have. If you want to email me later, or if you want to call me, just feel free to call me. It's pretty common. We do that with a lot AHJs in our territory. It didn't cost anything, so if you haven't, there's nothing wrong with asking questions.
Alrighty, well, thank you again, and we will be in touch.
Cool.
Let me stop this.